Okay, so number 4, we're going to be simplifying the square root of 300. The way I like to do these is to look for the largest perfect square factor of the number inside the square root. So the largest perfect square factor of 300 would be 100. I'm not just looking for any factor, the largest perfect square factor. So we have square root of 100 times square root of 3 gives you square root of 300 because 100 times 3 is 300. So then I take the square root of the perfect square, which is the 100, and I get 10. So then I have 10 times radical 3, so my answer is just going to be 10 radical 3. Okay? Okay, the next one, number 5. We have 2 over radical 3. We cannot have a square root in a denominator. It's not simplified, it's not clean. We want to what's called rationalize that to get it out of the denominator. To rationalize it, you multiply top and bottom numbers by the same number, and that number is your denominator. So we're going to multiply top and bottom by radical 3. Multiplying across, we have 2 times radical 3, which is 2 radical 3. Radical 3 times radical 3 is just 3. Any radical times itself is just a number on the inside. So my answer is just going to be 2 radical 3 for number 5. Okay, number 9. I have the square root of 15 divided by 3. Always reduce the fractions on the inside first if you can. I can divide 15 by 3 and I get 5. I cannot simplify that anymore, so my answer is going to be square root of 5. And that will be number 9. Number 10, I have the square root of 18 over 27. Reduce the radical first, or the fraction first. I will get square root of 2 over 3, so 18 over 27 reduces to 2/3. So then I can rewrite that as radical 2 over radical 3. It's the same thing. So now I'm going to rationalize, multiply top and bottom by radical 3, since that's in the bottom, and I'll have radical 2 times radical 3 is radical 6. Radical 3 times radical 3 is 3. So I'll have radical 6 over 3, and that would be my answer. All right, number 12. When we have radicals being added or subtracted, treat the radicals like x's or y's. Combine the like terms. So I will combine the radical 2's together. So I have negative 6 radical 2 minus 9 radical 2. I'll get negative 15 radical 2 plus 4 radical 3. So then that would just be my answer. I can't combine them two because they have different square roots. So that will be my answer for number 12. Number 14. Let's see what we can simplify first. I can simplify the first one. So 2 radical 99. The largest perfect square factor of 99 is 9. 9 times 11 is 99. The square root of 9 is 3. 2 times 3 would be 6. So my answer would be 6 radical 11 for simplifying that. Now I look at my second term, negative 3 radical 11. I can't simplify radical 11, so I leave that alone. Looking at 5 radical 44, I can simplify that. So the largest perfect square factor of 44 is 4. So I have square root of 4 times square root of 11. So then square root of 4 is 2. So then 5 times 2 is 10. So I have 10 radical 11. I'll bring down to negative 3 radical 11, and now I can combine them. So I would add or subtract the numbers in front. So 6 minus 3 plus 10 gives you 13. So 13 radical 11 will be my answer for number 14. Now for number 17, I would just multiply the outsides together and the insides together. So I'll have negative 20, negative 4 times 5 is negative 20. Radical 6 times radical 8 is radical 48. I can simplify the radical 48. The largest perfect square factor of 48 is radical 16. Plus 16 times 3 is 48. Take the square root of 16, I get 4. Negative 20 times 4 is negative 80. So negative 80 radical 3 is my answer for number 17. Okay, then my last one, number 20. I have a radical at the bottom, so I need to multiply top and bottom by that radical. So up top, I can't multiply the 8 by radical 5, but I can multiply the radical 7 by radical 5. So 8 radical 35 is up top. Radical 5 times radical 5 at the bottom is just 5. And then that's my answer. I can't reduce that any further. So my answer would be 8 radical 5 over 5.